Einen wunderschönen guten Morgen. Hello to everybody, or dzień dobry. But I think I changed to English because of the first language you don't understand. Polish, it's not my favorite. And so I try to do it in English, and I hope you understand a lot of what I want to say to you. I want to present you the CTCC project, the Creative Traditional Companies Corporation. And the CTCC project, best I can explain by a double triple helix presentation. Maybe all of you know the triple helix, but for those who don't, I will give you a short introduction. The triple helix is a university industry government relation interpretation model. And this is really working since about 25-30 years. And it's for showing us the changing dynamics between universities, between the industry, and between the economics. And of course, you can make it very much more complicated. And there are a lot of relationships between the innovations and the entrepreneurships which can be created out of this model. And at the end, it will be a very, very complex system, but I think that's boring. And I don't want to talk about that, because of this is more or less the organization idea behind all of that. I want to change to another triple helix. It is the same system, but it is much more visual and much more picturesque, and you can better understand that. It is about a project we have done about 8 years ago. 8 years ago, we had tomorrow. And it was a designship project, and it was a former project we did with students. And it was a research project before our CTCC project. We tried what is happening when you are doing a triple helix, not from government and universities and companies, but you do a triple helix project between the relation of design, economics, and engineering. And that's very interesting, because everybody of you knows the product development processes we know, and they are all working after each other. There is one of the economics who says, we need a product. Then came the technician one, the engineer, and he says, okay, I have an idea how it works. And at the end, there's the designer to make it ready for we can sell it. But that's not a good system, we think. And as we heard in our first lecture, our first lesson today, design is a very important thing we have to impact into this process. But I think not only design, also engineering and economics, and we have to think the three components clear together. Our problem is, of course, we have different professions, that's clear. But beside that, we have different languages at all. We have different tasks and different methods, and that will be the problem, because of they can't work together. We tried that in our first session 8 years ago. We had designers, we had engineers, and we had economists, and they don't really understand, they don't know what the task is, and they have completely different methods to work on that. And the problem is, we all know, a problem of communication. This is very complex, of course, communication model. And if we go inside that, there was in the one side the transmitter, and in the other side the receiver. And if the transmitter and the receiver don't have the same code, they can't understand. And that's why they have to have one common code. But it's very, very complicated to create a code which is understandable for designers, for engineers, and for economics. And that's why they only can do that by work. They have to train it. And we did the first thing. We changed the methods. We give, for problems of economic issue, the method of designers or the method of engineers. And we try to solve the problem with the different methods together with students of the three disciplines. It was very interesting, because of if they don't have their own method for their own problem, they have to discuss, and they have to discuss each other, and they begin to talk with normal vocabulary, not with the specific ones. They begin to talk about the methods. They have to create new methods, because of we all know the engineers have one special method. They have the point they stand, and they have the target to go, and that's the way to do it. and everybody is clear what is coming out there. And we all know designers are working completely different. They are standing here, they have a lot of ideas, they try out this one and this one and this one, and there comes out something completely different as they want to have. And we have to bring them together, we have to create an understanding between the profession, the language, the task and the method. And for that, of course, step by step, we changed a lot of other components in that system, and we made more and more complex tasks to try out what is happening when they don't have the same method. They have to speak in the other language, and they have a task which is not their own one. And at the end of that, there came a lot of understanding between the disciplines, and then we began to integrate real companies. We have real company problems, and we try to solve them with that student teams of the different disciplines. And at the end, we found out, and we made a real research project out of this to describe what is happening there. And with that description, we now can start to do it with real companies, with a real project, and to help them to get with a complex product development process with the integration of all of the three disciplines. And I would call it transdisciplinary, not interdisciplinary, because it is not between the disciplines, it's inside of the disciplines, and they have to do it all together. And this can be the profit for especially small industries, for SMEs, because of the big industries have their departments and they can't work as that. But small industries have the chance to get one person in their industry to make a complete change of the process and to get more effective processes. If you can't follow me, I can understand that. For that, I have a very, very simple example. And I try to explain it as a very simple task to develop a new coffee machine. We all know that. And the problem is, of course, we know the technology. Everybody knows there's a machine, there's a bowl of water, there's a thin metal pipe inside, and the water becomes boiling, is going through the metal pipe, dropping into brown powder. I don't know what is it. And there comes a brown liquid out, and we call it coffee. Unfortunately, the water is about 65, 70 degrees. And this is not coffee what is coming out there. You can try it, it's outside there. And but what is to do? Our problem is clear. The expectation of what we want to have is that. And there are a lot of these in our media markets or something else, and you can see hundreds of these machines, and they are a little bit different in the shape, and they are a little bit different in the technology and in the color. But they all work on the same principle. And that's a problem because of everybody knows what has to come out. It's the engineer way of development. But sometimes it happens that there's a break. And our thing is to find out what has happened there. Why they can do that and not having the coffee machine as we know. What has happened? How can we repeat? That's the main question we want to find out. And what is the system behind that? Why this process has changed? And I believe the main change is they don't want to produce a coffee machine, they want to drink coffee, of course. And we know all the principle from our grandmother. Grandmother has a boil on the oven, and when the water is boiling, she pours a little bit water in that coffee filter, and the coffee is squeezing a little bit, and after 1 minute, she put more and more water inside, and then there comes out coffee with 100-degree water. It's very, very tasty. And they did quietly the same as we know the Turkish want to cook coffee. Put the powder in a bowl, put the water in, wait about 3 minutes, and then you can drink it. But everybody knows the effect. You have to eat the coffee at the end. And they had a very good idea to have a good technology, boiling water. It's very simple. They have the good process, putting powder in the bowl, putting the water on, and they had a third component to put the coffee on the bottom that you haven't to eat it. And this is very, very simple, but it causes a lot of effects. At the one side, we get a completely new design. You've never seen that before, but it's a very pretty good design because of you can see what is happening. And that's why I have to believe the designer, the engineer, and the economists are included in that process. They did it together. They thought about how has it to be, how we have to create it, and at the end, how to sell it. And there they had a real problem because of you can't sell it in the media market because there's no cable on it. You have to find a new market at the end, and that's why the process has to be integrated. At the beginning, when you create that product with that new idea, you have to think about the market, and you have to integrate the thinking about over the market at the beginning. For that, you can find new markets, and they sell it in completely new other shops. They sell it by internet, and I think they are is a real good company with a real good output. That's what we try to do in that CTCC project. And tomorrow we will have workshops with some companies together where we start to find out what is their problem and how we have to solve that with that system. And of course, we can't do that tomorrow complete, but we can start changing some of these components, maybe the language or maybe the task, and to talk about the task and find out if we can find completely other solutions by that. I hope I was short enough for you and not boring, as I promised you at the beginning, and thank you for your audience.